Good morning, everyone, or good night, evening, depending on where you are in the world. Today we're going to talk about front-end security and why we should care about it. My name is Ilya Verbitskiy, and I'm a partner at Webstorting SRO. It's a web development agency focused on JavaScript and .NET consulting. We are doing development like Node.js, React, .NET Core. I've been working in software development industry for more than 15 years, mostly in finance and e-commerce sectors. After the presentation, feel free to contact me on Twitter if you have any question about presentations or in general. So let's start. Today we have 4 major topics. First of all, I will provide you a brief overview of the state of application security today and how it looks like. Then I hope to ruin the myths about static websites and that are completely bulletproof from hacking. After that, I will show you some bad guys techniques and tools and how they can abuse your site. And at the end, I will discuss the techniques on how we as developers can protect our apps and sites from being hacked. Okay, Akamai is one of the top CDN providers, but they also provide some really useful products like web application firewalls. On the following slides, you can see the total attacks per day blocked by Akamai web application firewall, and see like the numbers are not great, right? On the next slide, you can see the attack types distribution according to Akamai Wolf. And as you can see, the cross-site scripting attack is on the 3rd place now. And surprisingly, I've been monitoring it for a while, and it was like that for quite a long time. And those Akamai data is correlated with the latest OWASP top 10 list, as you can see on this slide. The OWASP top 10 is a standard awareness document for developers and web application experts. And it represents a broad consensus about the most critical vulnerabilities in web applications. The last document is from 2017, and new document is coming. And my gut feeling says that it's going to be almost the same, unfortunately. And of course, again, it's correlated with Akamai. Our vulnerability number 1 is injections, and it was always injections, because there are so many ways how you can inject bad code to apps. And XSS is somewhere in the middle. And again, I feel like in the next list, it's going to be a lot higher. So, let's recall how we can build sites in the past. We used plain HTML, ISP, PHP, and wrote everything from scratch. Then WordPress came to life, and many sites became like I call them plugin monsters. That are full of third-party plugins and components, and like even to do like simple thing like show for the gallery. And no doubt the sites were really slow. Then JavaScript raised, and we've got Angular, React, Vue, and the browser finally agreed on implementation of W3C standards. And how did we build a simple site today? As a React developer myself, I would use a static site generator like Gatsby, and then bundle my React single-page application into multiple HTML pages. Then I can simply copy to a server or to AWS S3 and host a website, and it's going to be like really fast. Of course, I need some backend, and for example, I have a contact form, and I want to send an email. It's not a problem nowadays, since there are dozens of SaaS products that can provide me API to, like, let's say, manage emails. And it's secure by default, right? Because we have HTML, CSS, JavaScript, nothing more, and no one can really hack me. Do you think are you sure? Let's move back to 2005, when MySpace still was popular. Does anyone remember Sammy or Space Hero attack? SAMI was a cross-site scripting worm that was designed to propagate through MySpace social network, and it was built by Sami Kamkar. Within just 20 hours, in the 4th October 2005, over a million users was infected by this virus, and was one of the most widespread viruses at the time. And the interesting fact is the worm itself is not exploited MySpace. And actually, after security audit, people found out that MySpace was quite secure. The problem was in the way how browsers execute JavaScript when they should not do that. And the problem raised in browsers like Internet Explorer and Safari on Mac. And see, like the virus itself is quite simple. So let's move on and let's go back to nowadays. I have a few examples of XSS attacks that are relatively fresh. Service Desk Plus is a popular solution across enterprises, and critical XSS vulnerability was found there that can give attackers full access to IT support system. TinyMC, a popular HTML editor, has XSS, and you can imagine how many CMSs can be affected, especially like TinyMC. It's one of the most popular editors in the CMSs. And I have there's a similar bug, but now it's in WordPress. So the issue in WordPress plugin affected 700,000 websites. And see, if you have a botnet of like those numbers of servers, that's not bad. Jenkins, that is probably the most popular CI/CD tool, reported more than 20 vulnerabilities in their plugins, and most of them are XSS. Jenkins is used in many enterprises as a main build platform, and you can imagine how bad it could be if they are hacked. And finally, XSS is #1 attack in 2019, according to CUK magazine. And based on the data, they say that nearly 40% of all attacks logged by security researchers last year were XSS. Okay, let's move on and take a look how XSS attacks may affect us, and what are some vectors, and what can go wrong really on your static site. One of the most common XSS attack vectors is hijacking legitimate user accounts by stealing their session cookies. This allows attackers to impersonate victims and access any sensitive information or functionality on their behalf. Let's see how it can be achieved. The attacker will send you a URL that has malicious payload, as you can see on the screen. And the script just reads your cookies and passes them to hacker server. The following example is a simple server listening on port 8080, and it just prints cookies on the console. Another practical attack vector for XSS is to use HTML and JavaScript to steal user credentials instead of cookies. This can be done by cloning the login page of the web application and then using XSS vulnerability to serve it to the victim. The following HTML code simulate LastPass login page, which you can send to that which can steal the credentials and send back to attacker server. The hacker in this example uses Beef framework. Beef is the browser quotation framework project. This is a server that has a collection of XSS exploits that you can use to do your attack. And the first step is always attacker sends a malicious URL that injects Beef scripts to the vulnerability page. After that, after victims visit the website, The exploit will show you the login screen from LastPass. And the last step, like if you trust your browser, you provide your username and password, and you can see them in the login panel. Another powerful attack vector for XSS is to use it to steal like personal information or some like sensitive data. For example, like cardholder data. Let's say if it's a banking application, usually you have a form to transfer funds, and it's secured by CSR by some tokens against CSRF attack. That's a like different attack. But in this case, if hacker has XSS exploit, then by using XSS, he can extract the token, send it back to the server, and then submit the form and transfer funds. And that's actually one of the reasons why most of the banks have the second factor when asking you for second factor during fund transactions. Now let's take let's take a look at another case. We have a simple website which doesn't have any sensitive information. For example, it's your company's presentation website with some marketing data. The attacker can use XSS to enforce a file download when the user is visiting the page. The file could be like anything like a virus or Trojan horse. And I don't think the organization will be happy knowing that the current or potential customers go to the website and they're infected. And these attacks represent a significant risk to the business, especially like some reputational risks. So on the slide, you can see an example. You visit the page and you have file download. And if you think that if it's like a legitimate company, then you will trust it. Let's move on. Cryptocurrencies have taken the world by storm in the past few years, making it hard to miss all the buzzwords like Bitcoin or blockchain. While the cryptocurrencies are far from new cyber criminals and hackers, but they open new ways of attack and new way of attack monetization. For example, on the screen you can see some JavaScript libraries that allow you doing mining. What attackers are doing, they find an XSS attack on your website and plug in some mining code, Bitcoin mining code, and whoever is visiting the site start mining cryptocurrencies for hackers. It was quite popular maybe in 2018 and 2019, and now since cryptocurrencies are not costing so much, we can see the attack less in the real world. Hackers can also install keyloggers on your site to track all users' interactions, and there are many scripts available on the internet how you can do that. And on the screen you can see one of them. And this simple keylogger is just like logging all keystrokes to my server running on Kali Linux, but it could be anything. XSS is also an unexpected source of initial port scans against internal networks. And again, there are multiple exploits on the web that allow you to do like port scan, and they work in the way that you're just sending requests to random ports and try to measure the timeout. And if I'm not mistaken, if timeout is less, then most probably the port is open. Again, in Beef, there are exploits to do that. So here's the screen how you can set it up port scan on Beef admin. And that's how the port scan looks in your browser. You will see just a lot of like unusual traffic. And the last but not the least, impact. is the website defacement. It's one of the simplest and yet effective way for attackers to target business or government institutions, and that's how they're basically changing the visual appearance of the website, and it could like any message, and and here you can see an example, or this is an example attack that will change the design, I would say, of my test website, and that's how it looks. The strange thing about those type of attacks is, let's say, someone clicks on the link and see that your website is defaced, but if the HTML script is in the URL, it will not be on your server, and it will be harder for you to track back what's going on wrong here. And then at the end of the section, I would like to talk about BEEF really briefly. BEEF is short for the Browser Exploitation Framework. It's a pen testing tool that focuses on the web security. It's open source, and it just makes XSS exploitation easier. BEEF comes with more than 100 built-in modules and exploits, and it also has an SDK, like JavaScript SDK, so you can build your own exploits. The good news is that vanilla BEEF is detected by most of antiviruses, so don't expect that hackers will just use those code. But the bad news are the code could be modified, and modified in the way that BEEF still works, but it's not detected by antiviruses. That's what you usually see in the wild. Okay, I hope I was able to answer the question why XSS is so dangerous for you, and even if you just have like a simple landing page. Let's move forward and talk about how the attackers can exploit your sites. There are 3 types of XSS attacks: reflect XSS, stored XSS, and DOM-based XSS. Let's review each of them. Reflected cross-site scripting arises when an application receives data in an HTTP request and includes that data with an immediate response in the unsafe way. Suppose a website has a search function that receives user-supplied search term in the URL. And in our case, in this example on the screen, it's a keyword. The application echoes the supplied search term in response to the URL. It's step number 2 and 3. If user clicks on the malicious link, then the script will be supplied by attacker. Will be executed in victim's browser in the context of the application. That's step number 4, and like cookies will be sent. The cookies will be stolen. This is an example of reflected XSS attack that just attached your cookies. Such attacks are usually blocked by modern web application firewalls. But again, if this is the case, then there are other ways how you can try to penetrate the browser and the firewall. The most common way is to use XSS threatener, because usually you see just like a short link, and definitely Wolf will see it as a legitimate, and antivirus will see it as a legitimate link most of the time. You can also go with like an extreme case. Just convert your link to a QR code, and like print it and just put it inside a university or even like IT conference. And according to social research, you will be surprised how many people will scan it and go to the link. The next type of attack is stored XSS. Stored XSS happens when an application receives data from an untrusted source and stores it to the database or whatever persistence you're using on your website. Then the data is shown to other users visiting the website. On the following screen, the attacker is adding comment on the page. The comment comes with a malicious payload and the just stealing user cookies. That's step number 1 here. Then the message stored in the database. Step number 2, and shown to the users who is visiting the website. And this attack could be even like more dangerous if there's an admin panel on the site. For example, you have moderators who can manage the comments. If the panel is vulnerable to XSS, the hacker can steal a privileged account. It's even worse. Let's have a look at an example. This is a vulnerable guest book, and attacker can post a message. This is a simple script that just shows an alert saying, hey, this is your cookie. After the post has been published, you can see the pop-up. And the good news, the good news again, stored XSS are mostly identifiable by web application firewalls, and going through those filters could be a lot more complicated than in the previous example. Now we can move on to the most dangerous XSS type, DOM-based XSS. It usually arises when JavaScript takes data from an attacker controllable source and uses it for execution. For example, a client-side redirect with window location object, or rendering content on a page using inner HTML attribute, or like using any modern framework. First, the attacker it's dangerous mostly because like all interactions is going on the web server, and the code is not checked by your web application firewall. So everything is inside your server, and you can only hope that your antivirus will see those unusual behavior and somehow alert you. And like this type of attacks with the huge amount of SPAs is probably it's racing, and probably it's going to be like #1 XSS vulnerability, XSS attack. So let's take a look at an example. The following form asks for your name, and the hacker can just type JavaScript code in the field and see the pop-up. The application has DOM-based XSS vulnerability, and you can see the pop-up on the screen. And please take a look at the URL. The application uses a location hash to create client-side URL. Such URLs are accepted by browser, and that's how we were doing like client-side redirects and like client-side URLs in the past. But the thing is, everything after hash is not passed to the server. Such malicious URLs will never come through WoW, and they will not be blocked on the server side. This is the application code. First, we are getting the URL from the user. And then the developer uses jQuery HTML function to render the message. And also, the application is listening for on-hash change event. So vulnerable code will be executed whenever your hash is changing in the browser. But HTML, CSS, and JavaScript are not the only vulnerable assets. Let's take a look at the screenshot. You can see there's only SVG image and a pop-up that is stealing your cookie. And it's nothing more than just SVG. So SVG is a graphic format that's based on XML, and under the hood, SVG documents are nothing more than simple plain text files that describe your lines, curves, shapes, colors, texts. It's a human-readable format, and it's easily to understood if you're not using like paths, and otherwise it's just awful like numbers. And you can also modify it via with CSS and JavaScript, and you can even have CSS and JavaScript inside. As you can see in the code, it's possible to add JavaScript directly to SVG, and the browser will execute it depending on the way you embed SVG. So sometimes they will execute, sometimes not. On this slide, you can see like when browsers can execute SVG and when cannot. Like what I see like most dangerous when you're using Webpack to package our resources. Sometimes, or most of the times, we inline small SVG files, and that could be a potential risk. Let's say if someone uh, can send you malicious SVGs and then embedded during your Webpack build, potentially your application could be affected. So just make sure your source control system is secure. Let's move on to the CMSs. Uh, modern CMSs don't appreciate if you're writing HTML by hand. Usually they provide a markdown editor to create content, and developers are assuming that markdown has a strict set of capabilities, and they assume that markdown will not allow users to inject some strange HTML, and they kind of feel the website is safe. Unfortunately, that's not the case. By default, markdown engines allow HTML rendering. For example, here on the screen, you can see that the attacker is adding some malicious JavaScript. As a result, you can see the pop-up with cookies. And whenever you're using like Markdown-based view engine, or it's not Markdown, it's like any view engine, please make sure that you configure it to escape HTML. So that should be like your rule number one: escape all HTML. You can say that you're building the apps using major front-end framework like React, Angular, and Vue, and the framework will make your app safer. Is it correct? The answer is yes and no. Yes, modern frameworks are doing a really great job to preventing XSS attacks against them. And no, they have capabilities that allow developers to have full control on rendering and on what content can be shown there. And they also have like vulnerabilities inside them. On the screen, you can see 3 ways of injecting unsafe HTML to your web pages for all 3 major frameworks. It's recommended to avoid using unsafe rendering in any framework, but when you do that, does it mean you're safe? Unfortunately, no, and that's our usual answer. Here on example, it's a simple React app that accepts a URL and creates a link. Do you see a problem here? Yes, attacker can use JavaScript URL to create a link, and when this URL will be rendered, and if user clicks on it, like the malicious code will be executed. So this is my example. I'm passing my JavaScript URL. I'm rendering it on the page, and booms. Once you click it, you see a pop-up with a cookie. And of course, this attack vector is applicable for any framework, like server side or client side. So please make attention whenever you're trying to render some URLs based on user input. JavaScript URL is one of the example of XSS filter evasion technique. It's recommended to stop a web application firewall behind your application, but they won't block 100% of the problems. WC standard is so big, and different browsers implement it in a different way, and a lot of legacy code in those browsers. All of those are factors that make XSS filter evasion technique even possible, and that basically complicates your developer's life. So hackers can try payloads like this, or even this, and there are like more than 100 different payloads that you can find on html5stack.org website, and they are applicable for different browsers. So yeah, please take a look, and you'll be surprised how bad the situation is. There are also other XSS evasion techniques, like HTTP protocol support different characters format, and JavaScript itself could be obfuscated in different ways. And on the following slide, you can see the obfuscated JavaScript code, and it just alert document cookie. And no one is doing obfuscation by hand. It's too slow, and it's really troublesome. There are tools like XSS that will automate encoding for you and obfuscation. We've just covered XSS evasion techniques, and there is no way an attacker or a pen tester will run all these payloads by hand. There are tools like XSS. It comes with Kali Linux to automate it. The latest version of XSS has more than 1,300 predefined exploits, and they're really proud of breaking in through like popular WoFs like Mod Security or F5 WoF. And it means that developers really have to pay attention on what they're doing. And this is not the end of the story. We're using WebStack to build mobile and desktop apps, and it may open even more critical vulnerabilities like remote code execution. Let's take a look to Electron. We have a simple login form here. If I type the wrong credentials, it will generate an error. But what will happen if I paste, let's say, a Node.js script to my email field? And the payload just runs Windows calculator. And it looks really strange, talking about the JavaScript form. Let's move to the code. So this is the vulnerable code, and it has a DOM-based XSS vulnerability. But why it can run like another process? The answer is in Electron framework. It has a capability to run Node.js code within the browser window. And like this is like a really high risk if you can run like full Node.js inside your web page. There are good news for all of us. Node.js is blocked inside Chromium window by default, and you really have to enable those features in Electron. Okay, what else we can hack? On this slide, you can see that JavaScript is available on mobile, on desktop, on servers, and even on IoT devices. So JavaScript is truly everywhere nowadays. Like it or you don't like it, but that's the present days. Okay, we've been talking about the bad guys techniques. Let's close it, and let's take a look how we can protect ourselves from being hacked. There are three main rules that will help you to block most of XSS vulnerabilities in your application. First, don't trust anyone. Use whitelisting for user input. Whitelisting means you specify allowed user input, for example, only English letters and spaces, and block everything else. Don't rely on blacklisting. So blacklisting is a technique when you allow everything except like certain symbols. And don't trust even admin users. So of course you should not trust them, and you should not trust data the data sources where the data is coming to your application. remember that we in the early examples we have the comments management system that has XSS exploit, and that's just one of the examples. So you admin user, you go to the comments management system, and let's say your comments are coming from like a third-party source, and by default you trust it. But again, if you have XSS in your app, it doesn't matter where the exploit is coming from. You should implement the content security policy from day one for your project. Content security policy is the name for HTTP response headers that allow you to restrict how resources such as JavaScript, CSS, or images are loaded in your browser. And again, if whitelisting doesn't work for you, make sure that you are using secure encoding libraries that understand the content and the context where your content is rendered. And the reason for using those libraries is you need like different techniques, different like parsers and like different techniques for rendering content, depending on if it's like an HTML tag or if an HTML attribute or a JavaScript code. The common approach of protecting from XSS is using HTML encoding for special characters, but that's not enough. The reason is that there are so many strange contexts within your HTML that the list of escaping rules can be like really complicated. You won't find any good reason to put untrusted data to those contexts, right? This includes like nested context, so you can have like a tag, like tags inside scripts, inside and inside tags. For example, like another example of nested context is you have a URL inside JavaScript. As you see, doing HTML encoding in the right way is very complicated. That's why you should not write the code yourself. You have to use some secure libraries to make sure that apps are safe. I would recommend using sanitization technique rather than plain text encoding. Input sanitizers will make sure that like all dangerous parts of your input, for example, HTML tags are removed and only the plain text is kept for further processing. Here on the slide, you can see the list of NPM packages that are helping with XSS sanitization. Like I personally like secure filters from Salesforce, but you can use any of them. Okay. DOM-based XSS, as I hope I showed you on the previous slides, are the hardest to prevent because server interaction is limited here. We cannot rely on the application firewall, and there are so many different ways how like JavaScript and HTML and HTML can be encoded. On the following slide, you can see like different encoding contexts within JavaScript and what encoding methods you should use to minimize the risk. And again, please don't write this code yourself. Just use some XSS protection and sanitization libraries. And like the basic rule is coming to the elder days. If you're rendering some text on your page that is coming from the user, please don't use, let's say, in the HTML attribute, use like text content, and don't put any untrusted data into your event handlers. It could be like very, very bad. A few more points on secure JavaScript development. Make sure that JavaScript variables are make sure that like if you're rendering some JavaScript variables that are coming from the server side, that they are properly escaped and sanitized by libraries. Don't use eval statement or or function constructor. The reason is they accept string as an input that may cause critical security problems if hackers can find a way to modify that, so they can eventually execute any code. And give extra attention to set timeout and set interval functions, because they also accept an input as a string. So you can have a potential like JavaScript injection here. And if your project budget allows buying a static code analysis tool, do it. They usually show a lot of false positive errors, but sometimes you can find real bugs. And here on the screen you can see some most popular solutions in this area. And even if you don't have budget for expensive static code analysis tools, you have to use open source alternatives. ESLint is #1 option for JavaScript in case we need to check some code quality and find issues before they appear on production. And on the screen you can see the list of plugins that I'm using myself and I found useful. And I highly recommend to any JavaScript-based project to start adopting it. This is how a JavaScript project looks nowadays at the end of 2020. It's all about open source, and sometimes in JavaScript we have too much open source. You need to understand that all third-party libraries, also all dependencies that you're using in your project are security risks. And who knows what vulnerabilities you can have inside your NPM modules. Some interesting data. You can see some sad facts here. Those facts are about the state of open source security published by Snyk. Snyk is a company specializing in tracking vulnerabilities in different third-party components. And they're not doing that great. Snyk hosts a huge database of disclosed vulnerabilities on the website. And you can freely go there and check the latest vulnerabilities in NPM packages. So even if you do nothing, really, most probably your application will have those security problems even before your code is shipped to production. Moreover, probably you'll have vulnerabilities even before you write any code. How we can fix it? There are two tools that I recommend. If your project is 100% pure JavaScript, just simply use NPM. It has built-in vulnerability database available for everyone to use it, and it can even you can get the list of vulnerabilities, and you can ask NPM to fix it. And if your project uses different platforms like PHP, like Ruby, then take a look to Snyk. Because they're tracking vulnerabilities for different languages, different platforms. Secure code practices is our first layer of defense, but it's not enough. Fortunately, modern browsers come up with an additional layer of XSS protection called Content Security Policy, or just simply CSP. To enable CSP, you need to configure your web server to return a Content Security Policy HTTP header that describes what content is allowed and what is not. Let's take a look at an example. This website allows content only from example.com. So your browser will ask, hey, can I get my main.js? Yes, styles, yes. But now imagine you have XSS vulnerability, and hacker is trying to get an exploit from his website, and browser will reject this call. This call. And you can also specify content security policy inside the meta tag on the page. But from what I've seen so far, HTTP headers are more widely used. This is how policy looks like. This policy says that you can load JavaScript files only from the site server or Google CDN. Styles can be loaded only from your web server, and frames, iframes, and web workers are forbidden. There are a lot of more attributes inside CSP that you can configure. It could be, you can say, hey, I'm loading my images from here, and I can load styles from there. Usually, it's hard to debug CSP. That's why browsers added additional report URI attribute. And this attribute allows you to specify HTTP endpoint where all CSP violation can be reported. You can also use content security policy report only HTTP header instead of standard content security policy header when you're in development mode. This header is used for debugging. In case, so if it's used, then browser will not block any static assets, but it will report all violations to your error tracing endpoint. And the violation reports comes as a just simple post request with JSON payload. This is how the violation report looks like, and it has, at least for me, it has enough details for further debugging. But that's not all. Google security team has developed a very useful tool to evaluate your CSP. Just go to cspevaluator.withgoogle.com. You paste your policy in there, and you'll get a report saying, okay, that's how you can tweak your policy, like some potential vulnerabilities, or you forgot about something. It's very, very, very useful, especially if you are new to this. There are a few other useful HTTP headers to improve your website security. First of all, extreme option. It's used to prevent the clickjacking attack. So clickjacking attack is an attack when when attacker take your website URL, embeds it inside an iframe, and then it has a transparent layer on top of it. So you go to Malicious website and you see, hey, it looks like my login form. You start typing in data, but you're not typing it into the iframe itself. You're typing it into the transparent layer, and that's how your data is stored. So just always use extreme option deny if you don't want your website to be hosted inside frames. Next one is XSS protection. This header doesn't let the page load when browser detects a cross-site splitting attack. It's like this header is enabled by default in Edge and Chrome, but it's being decommissioned now. And the general recommendation from Microsoft and from Google is to use CSP. And the reason for that was browsers are not that smart to prevent XSS attacks. And if you want to be safer, then go and define your policy. Then strict transport security. This forces your browser to communicate over HTTPS. So you just cannot access your website over HTTP anymore. And that's actually pretty useful, and I would suggest to use it all the time. And the last one is allow access control allow origin. It's a course header. Course is a tool that allow users additional HTTP HTTP. So Course is a tool that allow you porting different website, like different APIs from different domain names inside your web page from JavaScript, and it's really like widely used nowadays because you usually host your API in different domains. Okay, that's all that I want to share today. I hope you found some useful tips on this presentation. In the end, I would like to share some useful links that can help you to learn more about the front-end security. The first link is free training from Barbsuit creators. Barbsuit, it's probably the tool number one across web application pen testers. That's a tool where you can have full access to your HTTP interactions. It plays like a proxy, and you can do like any modification to HTTP requests. And it also has some attackers tools and some automation tools. If you're interested in this field, then definitely take a look. The other two links are the cheat sheets from OWASP about how to prevent attacks on your websites. And the last link, the last few links are information about CSP policies, how to write them, and finally the CSP evaluator that I found very, very useful for myself. Thank you all, and let's take a look if we have some questions.